Okay, so if 2024 is the year that we see these models actually do stuff for us,
Yeah.
and it's pretty early in the year,
Yeah.
like, and if correcting your grammar or rephrasing a sentence to sound more like, like a better way to phrase something is low-hanging fruit, what's the like, what's the really hard stuff that like we might see this year?
Yeah, that's a good question. I mean, one thing that's fairly obvious, ranging from Gemini to Apple published one a couple days ago, is increasing the modalities in the models. So modality again just means things that are other, in the case of a language model, other than text, either coming in or coming out. And so GPT-4 can take in images.
Okay,
And so it has an input modality other than text.
I see.
And what it's doing is it's turning that into an embedding, which is like an abstract representation of the image, and then that's passed along with the text embeddings. And so like if I give it an image of, let's say, a diagram for how my website should be structured, you can then generate code for all the different pages. And adding different modalities is useful for the same reason adding more than one sense to a person is useful. And so, text isn't really a sense for people. Like language is an interpretation of originally like audio, and now audio and text and signs and, different modalities. But like by adding modalities on the input, you can get the model to process data, and that's really useful. Like I've asked for a recipe from ChatGPT and then sent it pictures as I do things, and like tried saying am I doing this right? And that's really useful, right? That's incredibly powerful. On the output side, you obviously could have image generation be a modality. So GPT-4 doesn't have, I don't believe, an image generation modality on the output. Instead, it generates prompts for DALL-E. But I think Gemini, at least according to their technical report, has video generation as a modality and audio generation as an output modality. And so the possibilities when something can generate video, and you just saw, OpenAI published their new video generation algorithm, and they've saw that, it's just a pure video generation algorithm, but it's not part of a language model per se. It takes in a prompt, but they fixed a lot of problems that we used to have with video generation. The biggest one being temporal coherence, where frame after frame doesn't necessarily fit together in a logical way. Things get occluded and then disappear. So they fixed a lot of those problems, and a lot of people have been working on that for over 5 years, and a lot of these neural image generation algorithms. But if you can generate arbitrary video, obviously you can do things like generate an avatar for, the bot you're speaking to, but you can also Gemini, for instance, in their demo video, which was a little bit controversial in its authenticity, but they showed it generating a game, and so not just an image or video, but generating an interactive video that it might have, for all intents and purposes, was a game, right? They were showing a map game, I think.
Yeah.
And so when you add output modalities and you add input modalities, the number of applications really grows rapidly.
Yeah.
We're a voice company, and in general, right now, our voice generation and our voice recognition models are integrated with our LLMs, but they're not the same model. And there's pros and cons. Making them one monolithic model is architecturally simpler. It can result in the language generation being increasingly aware of audio inputs, and it allows the the speech generation to be increasingly aware of the intent and the emphasis coming from the text generation. And so, even though the human brain is modularized, it's very interconnected, and so even the language centers are much more tightly integrated with the centers that generate speech or that interpret audio than a model just passing text from one model to the next, or passing embeddings. And so the possibilities to have something that is much more natural, is more expressive with its voice, for us, those are things that are very exciting and that we're working on at GridSpace. And then there's also other really hard modalities like controlling a robotic platform, for instance. So OpenAI recently announced their Figure partnership, where they have a robot that it's implementing some robotic tasks while in a dialogue loop. And there's a lot of folks in the reinforcement learning community that have been trying to integrate work and progress in the language model field with aligning robotic platforms. But obviously, down the road, if you have a really good robotic platform, its usefulness, if you can control it with natural language, is a lot better. I know Boston Dynamics released a video a month or two ago where they had kind of like strapped GPT-4 to one of their like dog robots or something. And, but the truth is, like, obvious, the value there, I mean, is obvious to anybody. If you can just say like, oh, just clean the toilet to the bot, that's really useful.
Yeah.
Compared to, because there's only so much work that can be done over text, right?
Sure.
So like, I mean, a lot of the jobs that we're talking about in the wake of language models are things like programmer or marketing writers. For when it comes to image or video generation, we're talking about content creators. Those are the sort of jobs that are threatened. But if you can have it control a robotic platform, all of a sudden giving complex high-level instructions to something that can navigate the world opens up the same sort of automation we've seen in factories for decades to things like homes and offices, and that's a really big deal.
I mean, that's cool to have a robot that could do stuff. I would say that most people probably don't own a robot, and to productize something like that would probably take a lot longer than a couple of months. But like, so for the lay person in 2024, like, what would be a breakthrough to see in 2024? Like,
a breakthrough.
Like what
would surprise me? Or
yeah, like what's a complex thing that these models, like if you were trying to make them help you with stuff and do things, like what would be like a real eyebrow raiser for 2024?
Well, that's a good question, because everything I've described kind of we've already seen in the last couple months. So something that really is ahead, that would really shock me.
Like, we're not doing it, no one's doing it yet, that would...
that's
feasible.
One thing that I think is one hop away, but it's a hard hop away from language models, is really, really mastering tool use. And this is totally believable and is in active work by like OpenAI and by GridSpace. By tool use, I really mean things like using websites, right? So what's traditionally called like robotic process automation. What's interesting about this is a purely digital channel. So, you don't have all these extra problems that come with like controlling a robotic platform. But it's harder than it sounds, right? Like today you can go on GPT-4 and be like, browse the internet for this or whatever, and it can do things like perform a search, read a web page. But imagine you could say, go out, research a topic, and then do some task out on the internet, right? Like, so like, go out, like start taking jobs from Upwork, start programming people's websites, have them pay you.
And put it in my bank account.
Yeah, and then put it in my bank account. Like all of a sudden, like if you can really have something interacting with the world broadly through the internet, which is harder than it sounds to do generically, you can just let bots out on the internet and have them do anything.
Like
right?
a non-specialized bot.
Yeah. So, like let's say you're just like, okay, I want to find a doctor and I want to get an appointment this month, and I want to also the same day get tickets to see Dune 2 or whatever. And you give the bot that, and it could be emailing hundreds of doctors, it could be like writing support tickets, entering chat support, navigating websites, creating logins, scheduling various doctors, Googling doctors, and then later on, like navigate Fandango, look for a movie theater, whatever. And like we're seeing, a lot of folks working on solving sub cases for this, where it's easiest. And a lot of the things I'm describing are plausible to solve specifically. Where it really gets interesting is solving it generically. In general, in the AI field, artificial general intelligence, the kind of gold standard that we all aim for, something that's as smart as a person, really means a system that can solve multiple tasks that it's never seen before. And even just restricting it to just things you can do on the internet is really hard. I mean, there's CAPTCHAs on the internet. CAPTCHAs still keep out robots. You can write a bot that can beat CAPTCHAs, but have it do it in the loop of also 50 other things. Okay, that's harder than it sounds. And there's there's obviously a lot of really good uses, like having the bot do things for me on the internet. Like, I mean, the truth is, like most knowledge work jobs, it's just people with 5 web apps open. They have, Slack open, maybe they're a software engineer, they have Git open, whatever. All of those jobs being tied together by one agent working on your behalf, I mean, that's a really big deal. And, makes machines go from being just a pure conversation snippet to something that actually exists and has state and is achieving things. General tool use is something that everyone knows is valuable. General problem solving is a holy grail of AI. So what would really shock me is just you could you go to some general tool using agent and just tell it, I want you to make me $1 million. You have 4 days, and here's my eBay account, whatever.
I mean, there's so many instances of that in sci-fi where it's like you tell your AI to do something and then it does it, and usually in a bad way.
Have you ever heard that classic, that guy, he went on Craigslist and he sold a paperclip and then he used the money to, or traded his paperclip, I can't remember, and he kept trading up and trading up and trading up.
He got a Ferrari.
He got a Ferrari at the end or whatever. And imagine someone who just sent bots out and just had them wheeling and dealing on Craigslist all day, and they never actually picked up anything. They just got a paperclip from one guy and then exchanged the paperclip to someone else and then exchanged this to someone else. And at the end, they basically just get all those people to connect to each other, or they're doing having the bot do arbitrage or perform sales or whatever. Once you let the thing loose doing knowledge work via its tools, that's very different than something that just is isolated to a dialogue or has to be integrated as a dialogue.
So if we see the collapse of the entire internet economy, you'll be impressed.
I would always say that. Yeah.
Cool. I think that all is great. Do you have anything else you want to add to trends of 2024 to look out for?
Well, beyond, so we talked about multiple modalities. We talked about tool use. Those are 2 huge ones.
Yeah.
We talked about interfacing with the real world, so vision and robotics. A lot of those fields have unsolved problems outside of just pure learning. But those are some really big ones. I think one more that maybe people don't talk about quite enough is low power and embedded. This is important for a couple reasons. And NVIDIA announced at GTC yesterday their new newest low power GPUs. And what's interesting is twofold. One, if you want to run a model, especially if it's not the biggest model of all time, getting power down gets cost down, which gets the number of tasks that you can solve with language models up. And if you also get it lower power working on embedded platforms, smaller computers, that means you can start putting language models into things that are not on the internet. And so, which you will absolutely see in the next 5 years. And we don't see a lot of that right now. We see almost entirely cloud-hosted language models. But, if you could buy it doesn't matter if it's a refrigerator or a teddy bear, but a physical device that had modern vision or modern language models or modern speech models embedded and running in low power on a vacuum or on a house cleaning robot or on a teddy bear, obviously there's a lot of applications that require that, because even if the thing has access to the internet, it might not be reliable or fast enough for your use case, right? And so it's a very big deal to maybe at some point say the models are good enough for my use case. I'm going to freeze it, and then I'm going to target getting it onto an embedded platform, which just means a small computer or whether it's a Internet of Things device or a toy or some sort of cleaning or industrial machinery. Getting these models on board is a really big deal. Where you've already started to see some of that is image processing. So when you take a picture with your iPhone, there's some pretty sophisticated machine learning running on the phone. The reason images look so good on cell phone cameras isn't just that they have great cameras now, but they have much better cameras than they used to, but also that the GPUs on the and the the special coprocessors for image processing that they put have really sophisticated computer vision algorithms running on board. And not only that, they're trained just for that one device. And so they are trained just to take in, your cruddy iPhone camera and make it look like it came out of a better camera. And that includes, like, obviously there's like things that have been on there for a while, like, mimicking depth of field, which is just pure computer vision.
Yeah.
But there's other things like, image manipulation, making it look like it came out of a higher resolution camera or came out of a camera with better color response. And doing that using machine learning. And that's all happening on the device. So that way, even if you don't have the internet, your phone still looks good.
Yeah.
Right? Same goes for Siri. Like, Siri today mostly still is leveraging the cloud. And that makes sense because it mostly is doing cloud tasks. But same goes for like Google Assistant. But if, you had a full LLM in your phone and it was able to do all your phone tasks, like, you could be like, okay, I want you to do all this work. And you're just carrying your phone around, and your phone is doing that work.
Like on board,
board, yeah. And that might not sound like a very big deal, if you have the internet or it's something you want to have happen in the internet in general. But if you want it using your phone to do things like take pictures or do video calls, or you're not in a place with internet, or you're doing something that's just too too latency dependent to rely on the cloud, then it becomes a really big deal there too.
I mean, that's actually an interesting insight, because that's the trend of almost every technological advancement. Is it usually in the beginning takes a tremendous amount of resources to do this thing.
Yeah.
And it's like, computers used to take up entire rooms, and now they're in your pocket.
Yeah.
That might not be something a lot of people, including me, realize, because it happens on the internet. You don't have a computer taking up your whole room, and then fast forward to it being really small. Like, you don't really see the resources being used for your ChatGPT responses.
It's all implicitly kind of delivered to you by the restrictions on what you can use it for.
Yeah.
The cost, the limitations.
How fast it happens.
Yeah, and so, there's no doubt that Apple and Google want to get their language models on as part of the operating system, kind of like in the movie Her, right? And there's also no doubt that there's all kinds of embedded applications. It's always tricky because, one, what you can deploy in an embedded situation is often well behind what you can do in the cloud, because you just have less resources.
Yeah.
And so, there's exceptions, like if you buy a Tesla, there are like beefy GPUs or specialized boards, I think they did themselves, that are doing really sophisticated self-driving car stuff on board, because then you can't send that to the cloud, because, one, if you lose the internet and the car explodes, that's bad, and two, the latency is just too tight. So you have latency constraints and you have reliability constraints to keep you from relying on the cloud, so you have to have the compute on board. But the thing is, you're buying the car, so it's a big, expensive platform.
Yeah.
But if you're buying a teddy bear and you want the teddy bear to be able to talk to your kid, maybe the budget's $30. So you can't put a kilowatt rack hooked up on on an umbilical to your teddy bear. And so you want to put a state-of-the-art language model in there, but your resources are very constrained. However, when you do target one piece of hardware and you're really smart about it, you can get things into surprisingly small compute platforms. You see this in aerospace all the time. But also, you can do things like have an FPGA or even a custom chip that hard implements your neural network. It's just no one ever wants to either do that investment or they want to commit to that model, because models just get better all the time. But if you start to see stagnated progress on language models, you're going to start seeing people pursue more and more embedded applications. But I'm sure they already are. Because for instance, get a language model into your car where you can tell it really complex things like, hey, could you turn on the headlights but make the windshield wipers go slower, and also could you turn on NPR? Hands-free commands like that are very useful. Cars have been trying to put voice commands in for a long time, and for the most part, they either rely on cloud services or AirPlay or something to essentially do that for you. Mm-hmm. And then you have this cloud dependency, so you can have it do something critical. Or you try to do it on board, and it's poorly executed. And so it would be a really big deal for for more autonomous and embedded applications to be using language models in particular.
Cool. So in 2024, we're looking for more useful applications of AI. We'll be very surprised if you turn on the news one day and somebody has broken the internet's economy by making a bot that can just go on the internet with the task of make money.
Yeah.
And we're looking for more onboard computing for large language models.
Yeah, I think that's pretty much sums it up.
So that's what we're looking out for in 2024. If you're watching this and you have other trends that you think that we should talk about, or things that you think are going to happen, put them in the comments. And if you're watching in 2025, tell us how we did.
Yeah, or we'll have deleted this video.
Yeah.
Hello, thank you for calling GridSpace's YouTube channel. Did you make sure they liked the video and smashed that subscribe button?
Yes, I did.
And ask them to leave any questions or thoughts in the comments. It helps me a ton. Thank you for watching, and if you'd like to talk to me yourself, go to gridspace.com and click on any one of our demos. Thank you, and talk to you soon.
Thank you, Grace.